Welcome to the SmartTech Check podcast, hosted by Mark Vina, your home for candid, insightful, and provocative conversations about the smart home automation, security, smartphones, PC and console gaming, and much more.
Superior sensor technology is revolutionizing the pressure sensor market by developing intelligent system-in-a-sensor solutions. In addition to a traditional pressure sensor, we include additional electronics and software so that the system can be configured depending on the application. We call them application-optimized pressure sensors. So if you have a medical application, depending on the type of medical application, there are certain capabilities that are turned on and off. Same with our industrial and HVAC markets as well. We do focus on those three markets. We're not on the consumer space because we really focus on having extremely high accuracy with a very, very low noise floor to provide a much stronger signal-to-noise ratio. Our products are sold worldwide. We have customers throughout the world in each of the three main market segments we play in: industrial, medical, and HVAC. At the show, we really announced our multi-range technology. Not so much announced, but we really emphasized it as we have many customers utilizing it in order to improve their products. Multi-range allows one pressure sensor to support up to 8 factory calibrated pressure ranges, which is really unique in the industry. It allows a designer to design in one sensor across their product line to simplify their designs, as well as makes the manufacturing a lot easier. It also enables a company to release additional product variants quickly without having to change PCB or software, just by setting a different pressure range, which you can do with a simple software command. It's a unique feature that has really opened up a lot of doors, and in its way it's been a game changer for the pressure sensor industry.
My name is Edward Lee, the Technical Marketing Director, and I am with Synaptics, and today we're going to talk about FlexSense, our new product for IoT HMI. The first demo that I'm going to show you is a true wireless stereo demo that incorporates a slider. It also has the ability to do touch taps, double taps, triple taps. It also has a capacitive in-ear detection versus infrared in-ear detection for lower cost, low power. And we also incorporated a press function based on the inductive sensing here. As you can see, when I'm pressing it, this circle turns gray. It's detecting force at that point. Another thing that we added is magnetic hall detection, right? For detecting in-dock charging detection, as well as lid closure. The next demo is our gaming controller demo. And what we've done in this demo here is we've replaced all the mechanical buttons in this gaming controller. As many gaming controller manufacturers know, one of the first things that wears out in your gaming controller is either the mechanical buttons or the joystick. And what we replaced the mechanical buttons with is electrical buttons, what we call inductive-based buttons. And the advantage of these inductive-based buttons are multifold. One, it doesn't require contact. It's just measuring the magnetic field between a metal target and a magnetic field. The lower latency. It's faster. You don't have to wait for any kind of mechanical debounce. And because it's magnetic field, you can isolate the button from the rest of the mechanical industrial design, making the button waterproof, which is another key feature for a gaming controller because of the amount of sweat that builds up during a game. And then finally, we also added, in this gaming controller, charge dock detection. One other important feature about the inductive buttons, we can measure the displacement of the button within tens of microns. And this feature, measuring the displacement of a given button, is a very important feature in the gaming world these days, in particular multiplayer gaming applications. People are looking to set a threshold, a displacement. That threshold will trigger a gaming macro, will execute a whole series of gaming steps. And then this is a very popular feature for multiplayer gaming application. That is mechanical buttons with multi-level threshold setting. And that's all I have for today for the demos.
Hi, this is Luis from Synaptics. I'm about to show you the fall detection demo that we have. This is using our Katana SoC. It has 4 MPUs fully dedicated to running the model that we are going to show you over here. And this is targeted to low power applications. We are consuming about 30 milliwatts of power. So the demo, can you come? So here we have a TV where we are going to show you like the actual indication if a person fall or not. As you see, I'm under the camera and there's no detection. So let me fall. And you can see on the camera, there's a detection saying that a person fell, meaning that now I can ask for help, or all the system can ask for help for myself. If I go up, you will see that there's not anymore a fall detected. So this is target for elderly care systems and any smart building applications. This is mostly to show the Katana capabilities that we can do.
Hi, my name is Shaikh Amin Brown. I am Director of Product Marketing for Synaptics. And what I'm showing here is the DBM10L low power audio edge AI processor. This chip can run various audio edge AI such as applications such as wake word detection, command detection, sound event detection, and even user voice authentication. All of these demos I'm showing here. Let me actually start with the voice authentication. So this voice authentication allows to recognize a pre-enrolled user. I pre-enrolled over here earlier, so it's going to recognize my voice once it's ready. And you're going to see it's not going to recognize other people's voice. Hi, this is Shai. Is this recognizing me? 1, 2, 3. You see it says it's a match. And if somebody else speaks, it's going to be, of course, not recognizing them. And this is doing that at extreme low power. We're talking single-digit milliwatts for basically all of our demos. Next, I want to show you command detection. So I'm going to run a different demo. Oh, I think I have, hold on, a bit of a problem. Oh, now it's going to work. Okay. All right. Hey, Synaptics. Turn on camera.
Camera on.
So there's no camera turning on, but this device is just feedbacking that the command is being recognized. Hey, Synaptics. ARM system.
System on.
All right. So this is another example. This was an example of command detection. And now I want to show you sound event detection, which is very cool. So we can train the device to recognize various sounds, target sounds. This is machine learning based, as most of everything I show is. And I'm going to play sounds through this speaker over Bluetooth. The device is going to be listening, recognizing these sounds, and then playing back feedback through this speaker. So let me just get to my... All right, so we'll start with a baby cry.
Detected baby cry.
So you can hear, I don't know if the video can hear this, but detected baby cry. We'll do class, all right? And then, so I'll stop this. And the last thing we're showing is over here. We're partnering with a company called Imagimob for basically ML ops, so quick design, very fast design of machine learning models, creation of new models based on training data. So you can see this is the Imagimob Studio tool. There's training data over here that was added to the device, to the or to the studio. This is uploaded to the cloud for training, and you can either choose to import an existing architecture, neural network architecture, or generate a model list, a list of architectures in the ImagineMob cloud. And then you can select one of them and add pre-processing data, which over here you can see the features for, so like sample rate and feature count and things like that. This is stuff that we provide and gets integrated in the tool. And using both of these, that's basically all you need. And in the cloud, you can, so now you can press basically start new training job. This goes to the cloud and you get a set of trained models. Here we only have one that's completed in the cloud, and you can open it to see some of the characteristics, such as how many predicted observations, various validation statistics, various test statistics, etc. And then once you're done and you've selected the model, you can right click here, and so what you get from the ImagineMob cloud is an H5 file, which is a Keras file basically. You can compile that for D10L, the DBM10L, the target, using our own compiler, which is again integrated with the tool. And so once you finish that, you get a model, you can load the model to the device, and you can run your application.
Hello, my name is Pirik Lanes. I'm here on behalf of Infineon Technologies, Applications Engineer. And here I'm going to be showcasing our Smart TV 60 gigahertz radar tracking, motion tracking demo. So essentially what this is we'll have a 60 gigahertz radar called the BGT60 LTR13. And what it's doing in this application is just doing segmentation and tracking. So basically it could be able to pinpoint people where they're at in front of the TV. And the proposition for that initially was just presence detection. You know, if there's someone in front of the TV, it'll leave the TV on, and if you leave, it'll turn off for power saving. But we wanted to take it a step further and do people tracking, just to show that we can do it. And then what some applications on top of that would be audio beamforming, so we can like pinpoint where someone is and like have the audio directed towards them. That could be an application for that. But without further ado, we can just show you a little demonstration of it tracking me. So right now there's no one in the field of view. So right now it's tracking me. Walking away. I'm just gonna walk this way.
Okay, so what we have here is basically our battery-operated sensor fusion-based glass break alarm system. So we use a microphone and a pressure sensor, as well as an acoustic event detector to detect whether a sound in the environment is related to glass break. Then we check for pressure change in the room to see whether glass break is actually related to burglary. This will basically help to initially eliminate false negatives or false positives on glass break detection, which you would find currently, unfortunately, with a lot of existing glass break sensors. Okay, we use one of our analog microphones for that purpose. A partner company acoustic event detector, as well as our digital pressure sensor and one of the PSOC6 microcontrollers to control the entire circuitry. The good thing about this is it's machine learn based, so the system can learn and can be adjusted accordingly to other sound detection, for instance, not just glass break, but maybe also gunshots, dogs barking, kids crying, etc. So it is adaptable basically to different sounds and different disturber sounds, as we would call it.